Hello friends, today we will discuss about the use of steam table and using steam table, how to find out the properties of steam of various qualities such as wet steam, dry saturated steam and superheated steam. To find out properties of steam, we will use steam table, and from that steam table we will be finding out enthalpy of steam, entropy of steam, specific volume of steam, density of steam. Such things we are going to find out how to use steam table to find out the properties of steam that we will see in this lecture. The very first, the steam table is given in two forms or two ways. The steam table for saturated water is given in terms of saturated temperature of water is given. So this is the steam table, saturated water and steam temperature table. So in this, data is arranged in such a way that we have to find out properties of steam based on the temperature of steam or saturation temperature of steam. So very first column in this table indicates pressure in bar. So here in this column, the pressure of steam in bar is given at this saturation temperature. Say for example, at saturation temperature of 4 degrees Celsius, the pressure, absolute pressure of steam is 0.00813 bar, whereas specific volume of, if it is water, it is represented by Vf, and this is the value of specific volume in meter cube per kg, and the specific volume of dry saturated steam is given as 157.27 meter cube per kg. So at this temperature of 4 degrees Celsius, saturation temperature of 4 degrees Celsius, we call this as a saturation temperature. Saturation temperature, at this saturation temperature, we get specific volume of water, specific volume of dry saturated steam, then enthalpy of water in kilojoules per kg, specific enthalpy per unit mass of the steam is given in this column. So very first column in this section is 16.8 is the enthalpy of water, saturated water, and this is enthalpy of evaporation, or we call this as latent heat of vaporization or evaporation. So at this 4 degree saturation temperature, enthalpy of evaporation is 2492.1 kilojoules per kg, and this is nothing but steam enthalpy. Steam enthalpy means this is enthalpy of dry saturated steam. This is enthalpy of dry saturated steam. So if you find out this sum of this enthalpy of water, saturated water, and enthalpy of vaporization, this works out to be Hg. So Hg is equal to Hf plus Hfg. So enthalpy of dry saturated steam is enthalpy of saturated water plus enthalpy of evaporation or latent heat of vaporization. Then after that, this section gives us specific entropy of steam. So here first column gives entropy of water in kilojoules per kg degree Kelvin. So this is the entropy of water at saturation temperature of 4 degrees Celsius, corresponding to 4 degrees Celsius saturation temperature. This is the entropy of water. So this is entropy of evaporation. So sum of this Sf plus Sfg is Sg. So this is the entropy of dry saturated steam. Sg is equal to Sf plus Sfg. So this is nothing but a table given for properties of steam on the basis of saturation temperature, on the basis of saturation temperature is given here. So this column indicates saturation temperature. Based on saturation temperature, corresponding to the saturation temperature, we can find out pressure of steam, then specific volume of water, specific volume of dry saturated steam, then enthalpy of saturated water, enthalpy of evaporation, then enthalpy of dry saturated steam, entropy of water, entropy of evaporation, and a total entropy of dry saturated steam. So this is one kind of steam properties arranged based on the saturation temperature. Similarly, properties of steam are also arranged on the basis of pressure. So this is arranged on the base of pressure. So corresponding to the pressure, just like in previous table, we have seen the properties which we have taken were on the basis of temperature. So these two columns are interchanged. Only first column is made as second column and second column is made as first column. So corresponding to any pressure. So for example, we take example as 15 bar. At pressure of P is equal to 15 bar, we can get saturation temperature as 198. In earlier case, so if temperature is given, from that temperature we can find out pressure. Now here pressure is given, and from that we can find out temperature. So here this is saturation temperature at 15 bar is 198.3 degrees Celsius. So this is temperature, saturation temperature we can call. So this is specific volume of water in meter cube per kg. This is specific volume of dry saturated steam. Vg is nothing but specific volume of dry saturated steam in meter cube per kg. So this HF is enthalpy of water, saturated water in kilojoules per kg, and this value is nothing but enthalpy of evaporation in kilojoules per kg, and this Hg is nothing but again enthalpy of dry saturated steam corresponding to the pressure 15 bar. Again, similar to that, we can find out entropy of water. So in this case, entropy of water is 2.314 kilojoules per kg degree Kelvin. Entropy of evaporation is nothing but 4.127 kilojoules per kg degree Kelvin, and this is nothing but Sg, which is sum of these two. So if we add Sf and Sfg, we get Sg. So this is 6.441 kilojoules per kg degree Kelvin. So corresponding to this 15 bar pressure, so these values we can obtain. So this is how we can find out values corresponding to pressure and corresponding to temperature. So if temperature is given, say for example, we take example of 15 degrees Celsius. So sorry, we will take it in this next table. We can see here. So in previous table, this is a 35. Pressure of 15 bar, it was 15 bar. 15 bar. No, we take 15.5, 15.5. Okay. So here, if we see corresponding to pressure 15.5 bar, saturation temperature Ts is 200 degrees Celsius. So this is 15 bar. Approximately we consider this as 15 bar. This is a pressure column. This is pressure column, and this is saturation temperature. Corresponding to 15 bar, temperature of saturation is 200 degree. And in previous case, if you see 15 bar, corresponding to 15 bar, saturation temperature is 198. So only these two columns are interchanged. You can see here 215, and here in previous case it is 15, 200, not exactly 200, it is 198. So here it is 15.5. So other values are approximately same. If we consider this, yes, Hg value, this is Hg, HFG and HF. So Hg value, if we see here at the pressure of at saturation temperature 200 degrees Celsius is 2790, and here also this is 2789. So approximately same values we will get here, 2789, here 2790. So it may be with reference to the pressure, or it may be with reference to the saturation temperature. These values are not going to change. Only these two columns are going to interchange. Saturation temperature comes here, pressure goes here. So these columns are going to interchange with each other, but Rest of the values are going to remain same. Corresponding to 15 bar, if we see, same values corresponding to 15 bar we will get here. So same table is arranged in different ways. So that is nothing but the properties of steam based on saturation temperature, or properties of steam based on pressure in bar are given in two ways in the steam table. So if we want to find out properties of steam corresponding to saturation temperature, then we will use temperature based table. And if we want to find out properties of steam based on pressure, then we will use pressure based table, steam table, and we will find the values of our properties at particular pressure or particular saturation temperature. So now coming to this is the table corresponding to pressure. So based on pressure it is given. Now say for example, pressure is given as P is equal to 13.25 bar. So we want to find out saturation temperature, then we want to find out Vf, say, then we want to find out Vg, Hf, Hfg, then Hg, Sf, Sfg, and Sg. So how to find out these values? So 13.25 bar is not given in this table, but it lies here in between 13 and 13.5. Exactly this 13.25 is average of 13 and 13.5. So always we will find out average of these two, find out temperature. So temperature we find like this: 191.6 plus 193.3 divided by 2. Average of these two will give us temperature. Then Vf we find out average of these two. So because 13.5 is in between 13 and 13.5, so 13.25 is average of 13.5 and 13. Therefore we are going to take average of these properties. So here 0.001144 plus 0.001146 divided by 2. So this gives us specific volume of water, then specific volume of dry saturated steam. Again we take average of these two. So here we will write as 0.15114 plus 0.14576 divided by 2. So this is the average of these two values. We will get the specific volume at 13.25 bar, because in this table we won't get 13.25 bar. Therefore we have to interpolate. We can call this as an interpolation. Again, to find out values HF, HFG, we have to take average of these all values, and then we get the intermediate value of properties at the given pressure. So this is how we are going to find out values at 13.25 bar. Now question is like this: if pressure given is 14 point, P is equal to 14.6 bar. If pressure is 14.6 bar and here values given in this table are 14.5 and 15 bar, and how to find out properties at 14.6 bar? Say we want to find out temperature, we want to find out specific volumes, everything we want to find out at pressure of 14.6 bar. How to interpolate? So what is difference between 15 and 14? 15 and 14.5. So 15 minus of 14.5. So difference is 0.5. So here difference is 0.5, and we want to find out at pressure of 14.6. So first pressure is 14.5. 14.5 plus 0.1. So this gives us 14.6 bar. So 0.1. So this 0.1 is fifth part of this 0.5. So 0.5 divided by 5 is equal to 0.1. So we want at pressure of 14.6. So to find out 14.6, initial value is 14.5, and to this 14.5 if we add 0.1 we get 14.6. So difference between 15 and 14.5 is 0.5. So if we divide this range of 14.5 to 15 into 5 divisions, so each division will be of 0.1. So that's why what we have to do, we have to take difference of these two values. So for example, we want to find out saturation temperature. So to find out saturation temperature is 196.7 corresponding to 14.5 bar, and it is 198.3 corresponding to pressure of 15 bar. This is at 14 bar, this is at 15 bar, 14.5 bar. So this is in degree Celsius, this is in degree Celsius. So number of divisions between 14.5 and 15 is 5 divisions. Each division is having step of 0.1. So here also we take difference between these two. 198.3 minus 196.7. So subtracting this, 13 minus 7, so this is 6. 7 minus 6 is 1. 0, 0, 1.6. 1.6 divided by 5. So this works out to be 0.5 is a 15, 5.32. 0.32 is equal to 1 for each division of pressure. Say if we increase pressure 14.5 bar, at 14.5 bar it is 196.7 degrees Celsius. So at pressure of 14 bar, saturation temperature is 196.7 degrees Celsius. So at 14.6 bar, so this will be 196.7 plus 0.32. Then at 14.7 it will be 196.7 plus 0.32 plus 0.32. So for each division 0.6, 0.7, we will add 0.32 to each. 14.8. So at this 196.7 plus 0.32 plus 0.32 plus 0.32. So like this, minor changes you will find out. So you can find out at any pressure between 14.5 to 15 by adding 0.32. How we get 0.32? First we have to take difference between a higher value and lower value, then we have to divide it into 5 divisions. So how many divisions we have to go ahead of 14.5? So at 14.6 means one division, only 0.32 we need to add. So if we want to find out at 14.7, then two divisions, so we have to add 0.32, 0.32 twice, two times. So we'll get at 14.7 bar. So like this we have to add the value of each division to interpolate between 14.5 to 15 bar. So this is we call as a interpolation. Generally what people do is, say this is 14.6 bar is asked. So 14.6 bar is approximately equal to 14.5. Therefore they used to take all properties at 14.5 bar. They won't go for interpolation. If it is 14.9 bar, then 14.9 bar is approximately equal to 15 bar. They take properties at 15 bar only. So depending on these values, so whether it is close to 15 bar or 14.5 bar, so they used to copy values at a particular pressure only. So sometimes we need to interpolate if we want accurate answers, and if we don't want any accurate answer, then we can approximate. So if it is 14.6 or 14.7, then we used to take 14.7, then it is taken as 14.5 approximately, and then properties at 14.5 are copied. If it is 14.8 and 9, 14.8, 14.9, then it is approximated to 15 bar and values at 15 bar are copied. So this is how the interpolation is done. So this is not that important to interpolate, only just if we want to have accurate values at given pressure, exactly at given pressure, then we need to interpolate. Otherwise we need not to interpolate the values of pressure and to find out the properties of steam. So now we see this table. In this table we will consider one pressure P is equal to 10 bar. So at pressure P is equal to 10 bar, at pressure P is equal to 10 bar, we want to find out properties of steam. Properties of steam means enthalpy of steam, entropy of steam, we want to find out. So these values we have to copy, and then we will find out the values. So here let us consider one problem, and that problem is like this. Problem is properties are given. 1 kg of steam at 10 bar, say 1 kg of steam at pressure P is equal to 10 bar. We have steam at pressure of 10 bar, and we have to find out what we have to find out here is the enthalpy then second one is entropy, then specific volume, of steam. Then we will find out these three things are sufficient. Specific volume, reciprocal of specific volume gives us density. So these three values we will find out. And for steam, for three types of steam, number one, steam is wet with dryness fraction X is equal to 0.8, say dryness fraction is equal to 0.8. Second thing, we find out these properties enthalpy, entropy, specific volume for dry saturated steam. Dry saturated steam. And third one is specific volume, enthalpy and entropy for superheated steam. If temperature of steam is equal to 200 degrees Celsius, this is the problem to find out enthalpy, entropy, specific volume for steam which is wet, dry saturated and superheated steam. So pressure of steam is given to us. So at this pressure P is equal to 10 bar. So we will write these properties from steam table: pressure, temperature of saturation, Vf, Vg, then HF, HFG, Hg, SF, SFG, then Sg. So these properties we have to take from steam table at a pressure of 10 bar. So pressure is in bar, temperature is in degrees Celsius, specific volume is in meter cube per kg, this is in meter cube per kg, enthalpy is in kilojoules, per kg, specific enthalpy in kilojoules per kg, kilojoules per kg, entropy is in kilojoules per kg Kelvin, kilojoules per kg Kelvin, again entropy in kilojoules per kg Kelvin. At pressure of 10 bar, saturation temperature is 179.9, 179.9. Vf value is 0.001127, 0.001127. Then this is 194.19430, 0.19430. HF value 762.6, HFG value is 2013.6, then Hg value 2776.2, 2776.2. Then SF value is 2.138, 2.138. Then SFG value 4.445. Then SG value 6.583, 6.583. So these values are known to us now. So first we consider one type of steam, wet steam. Wet steam having dryness fraction X is equal to 0.8, means 80% of water is converted into dry saturated steam and 20% water is still not converted into steam, dry steam, that is water is in suspension. So now first in this we find out enthalpy of steam. So to find out enthalpy of steam, enthalpy of wet steam is equal to, formula is HF plus X HFG. HF value we know, HF value is 762.8, sorry 0.6, plus dryness fraction X value is 0.8, which is given in the problem itself. Then HFG value is 2013.6. So if we simplify this, enthalpy of steam, this works out to be 2373.5 kilojoules per kg. So this is the enthalpy. And second we want to find out the entropy of steam. Entropy is represented by S wet. Entropy of steam is given by SF plus X SFG. SF value is 2.138, 2.138 plus dryness fraction X value is 0.8 into SFG is 4.445, and on simplification we get this entropy of wet steam as thermal. Here it is, I think Okay, just if we simplify, we'll get this entropy. Let's use calculator. So this works out as 5.694 kilojoules per kg degree Kelvin. And third bit which we want to find out is specific volume of steam. Specific volume of steam. If steam is wet, so it will be X into specific volume of wet steam is X times Vg. X value we know, that is 0.8 into Vg value is 0.19430. So this works out as 0.1554 meter cube per kg. So this is about the properties of steam. To find out enthalpy of wet steam, entropy of wet steam, then specific volume of wet steam. Then we assume that steam is not wet. If it is dry saturated steam, then we'll have to find out same values, assuming that dryness fraction X is equal to 1. If steam is dry saturated, then value of dryness fraction becomes 1. So now once again, for dry saturated steam, for dry saturated steam, we have to find out, number one, enthalpy H. For dry saturated steam, we call this as Hg. So this is nothing but Hf plus Hfg. Directly these values are known to us, or else we can directly copy value of Hg. So this is equal to Hf is 762.6 plus HFG value is 2013.6, and if we add this, we get Hg, that is 2776.2 kilojoules per kg of steam. Then we want to find out entropy of dry saturated steam, that is given by Sg. This is nothing but Sf plus Sfg, which is equal to, again value of Sf is 2.138 plus SFG 4.445. If we add these two values, we get Sg value as 6.583 kilojoules per kg degree Kelvin. And third one is specific volume Vg, which is directly given in this steam table, that is 0.1943 meter cube per kg. So now third case is given as steam is superheated steam. Steam is superheated with a temperature of superheated steam T sup is 200 degrees Celsius. So in this problem itself it is given that steam is superheated. So if steam is superheated, then how to find out enthalpy, entropy, and specific volume of superheated steam that we will see here. Number 1, enthalpy of superheated steam, HSUP. Enthalpy of superheated steam is given as HF plus HFG plus CPS, specific heat of steam, into TSUP minus TS, where TSUP is temperature of superheated steam and TS is temperature of saturated steam, saturation or saturated steam. So here HF value we know 762.6, already we have used it here, and HFG value is 2013.6 plus specific heat of specific heat at constant pressure for steam is 2.1 kilojoules per kg degree Kelvin. So this is taken as 2.1. This is always 2.1 kilojoules per kg Kelvin into temperature of superheated steam, which is given in the problem, is 200 degrees Celsius, minus temperature of saturation is taken from steam table that is 179.9 degrees Celsius. So here 179.9 degrees Celsius. On simplification, we get enthalpy of superheated steam as 2818 kilojoules per kg. And second, we want to find out the entropy of superheated steam, HE, entropy of superheated steam. Entropy of superheated steam, this is equal to entropy of superheated steam is equal to SSUP is equal to SF plus SFG plus CPS natural log TSUP divided by TS. So here SF value we know, that is 2.138 plus SFG value is 4.445 plus CPS value is 2.1 into natural log temperature of superheated steam in degree Kelvin. So here this is 200 degrees Celsius is given plus 273 whole divided by saturation temperature, which is known to us, is 179 from steam table, 179.9 plus 273. So on simplification, we get this entropy of superheated steam as, so this works out to be 6.674 kilojoules per kg Kelvin. Then third is specific volume of superheated steam, VSUP, is obtained by Vg into TSUP divided by TS, saturation temperature. Vg we know, Vg is 0.1943, which is given in the steam table, 0.1943 into temperature of superheated steam is 200 degrees Celsius plus 273. So this must be in degree Kelvin, this temperature of saturation and temperature of superheated steam. When we substitute in this specific volume equation, it must be in degree Kelvin. Here it can be in degree Celsius. So to find out enthalpy of superheated steam, temperatures can be in degree Celsius or degree Kelvin, but here it must be in degree Kelvin. So divided by saturation temperature is 179.9 plus 273. On simplification, we get this specific volume as 0.203 meter cube per kg. So this is how we find out uh, enthalpy, entropy, and specific volume of steam. So sometimes we need to find out dryness fraction of steam. So there are two conditions where we need to find out dryness fraction. So just let us see the two conditions where we need to find out dryness fraction of steam. So some of the cases, steam is passed into the calorimeter, and after calorimeter properties will be given, and before throttling in the calorimeter the properties of steam will be given. So steam is wet before entering into calorimeter, and after coming out of this calorimeter, so steam becomes superheated or dry saturated. So depending on that, so enthalpy of wet steam enters into the calorimeter and leaves calorimeter in the form of superheated steam or dry saturated steam. So when it is passed through the throttling calorimeter, enthalpy before throttling is equal to enthalpy after throttling. So before throttling, the steam is wet, so enthalpy of wet steam is given by HF plus X HFG. So at pressure, say for example P in, and this is pressure at P out. So we know pressure P in. At pressure Pn, we find out the value of HF from steam table, we find out value of HFG from steam table. Only unknown is X dryness fraction. So on right hand side, steam becomes superheated. So here HF plus HFG plus CPS T soup minus TS. When steam leaves this calorimeter, sometimes it becomes superheated or sometimes it becomes dry saturated. So if it becomes dry saturated, then this term becomes 0, because saturation temperature and superheated temperature is equal to each other. Therefore this term becomes 0, and therefore this term also becomes 0 if steam is dry saturated when it comes out of the throttling calorimeter. If it becomes superheated, then this formula we have to write. So at pressure P out, we find out HF value, HFG value, then TS value. T soup will be known to us, CPS is 2.1. So everything is known, only unknown is X. So the values of HF and HFG on left hand side are at pressure P in, inlet pressure in bar. So pressure, say for example inlet pressure is 10 bar, so these values are taken at 10 bar, and outlet pressure after throttling pressure is going to decrease. Say for example it is 2 bar, outlet pressure is at 2 bar, outlet pressure is 2 bar. At outlet pressure 2 bar we get these properties: saturation temperature and temperature of steam coming out of this calorimeter T soup will be given in the problem. So for example it is 200 degrees Celsius. So temperature of superheated steam is known. Everything in this term on right hand side is known. At pressure 2 bar, temperature of steam is known. Saturation temperature is taken from steam table. CPS is assumed as 2.1. So everything on right hand side is known. On left hand side only X is unknown. So from this dryness fraction X can be obtained. So this is one example where we find out dryness fraction X. So how to find out dryness fraction in throttling process. Now second thing is, steam is expanded adiabatically. So when steam is expanded adiabatically, entropy before expansion is equal to entropy after expansion. S1 is equal to S2. So this is entropy before expansion or compression, and this is entropy after expansion. So quality of steam in the expansion process is going to decrease. So here what happens if it is expanded isentropically or adiabatically, then entropy before expansion is equal to entropy after expansion. So before expansion steam is superheated, and after expansion it becomes wet. So after expansion steam is wet, before expansion it is superheated. So to find out entropy of superheated steam, we have formula SF plus SFG plus CPS natural log T sup divided by Ts. So these properties are at pressure before expansion. Say for example pressure P1, at pressure P1 we find out all these properties. So all these properties will be known to us before expansion, and after expansion steam becomes wet. So to find out entropy of wet steam, formula is SF plus X SFG. So here these properties are taken at pressure P2. So SF can be known, SFG can be known at pressure P2, only X is unknown. So substituting all known values SF, SFG, CPS, TSUP, TS corresponding to pressure P1 and SF, SFG corresponding to pressure P2. So only unknown remains X, and in that case we get a dryness fraction. So here the two cases where we need to find out dryness fraction of steam. In case of throttling process, enthalpy before throttling is equal to enthalpy after throttling. In case of adiabatic expansion or compression, entropy before expansion is equal to entropy after expansion. That is to be equated, and here we can find out dryness fraction X. So this is how we use steam table, and by using steam table we find out enthalpy, entropy, specific volume, density of a steam, and at the same time, so if we know properties of steam before throttling, after throttling, we can find out quality of steam before or after throttling, as well as if we know properties of steam before expansion, adiabatic expansion, and after adiabatic expansion, we can find out quality of steam after adiabatic expansion, that is dryness fraction of steam or temperature of superheated steam in case of compression that can be obtained. So for we people to have the basic idea about using this steam table and finding properties of steam at different pressures, this much is sufficient to go ahead with the calculations related to the steam generators.